Hi, everyone. We're here. Last session. Very exciting. Let me zoom in a little bit so we can get started. Hope you guys are ready to go. And looks like I am crooked. Wrong way. Or that way. Okay. So let's get going. Final exam tomorrow. You guys have been doing a great job. So excited for you guys that this is going to be the end. Hopefully you guys are passing so that you don't have to take it in summer school. All right, let's go. So this is taking it way back to the very beginning and how to find x and y intercepts, how to write the equation of a line, that kind of stuff. So let's get going. All right, finding an x-intercept. How do you find an x-intercept? You make y equal to 0 and you solve. Okay, make y equals 0 and you solve. So I can zoom in a little bit for you guys. Okay, so here's our equation. We're going to make y equal to 0 and we're going to solve. So we're going to get 3 times 0 minus 6x equals 6. That obviously is 0, so I get negative 6x equals 6. Divide out both sides by negative 6, and x equals negative 1. So my x-intercept is negative 1 comma 0. Write it in slope-intercept form. Right now it's in standard. Well, it's kind of in standard. The x should be on the other side. But slope-intercept form, remember, is y equals mx plus b. So we're going to go ahead and write it that way. I'm going to go ahead and move my x over here. So I'm going to add my 6x to both sides. And I get 3y is equal to 6x plus 6. I'm then going to divide out by 3 for everything. And then y is equal to 2x plus 2. And right there, I am in slope-intercept form. Find the slope of the line. Well, the good thing about being in slope-intercept form is you have your slope. Your slope is right there, so your m is equal to 2. Remember, m is the variable. Little m is the variable we use for slope. And then you need to sketch the graph, label the x and y intercepts. So my equation of the line is y equals 2x plus 2. Remember, you start at your y-intercept, starting at 2. And that's like 2 over 1. So I'm going to go up 2 over 1. And then you just connect the dots. There. Okay. I wanted you to label the x and the y intercepts. Okay. We know our x-intercept is at negative 1. It's right down here. So our x-intercept's at negative 1 comma 0. And our y-intercept is at 2 comma 0. So that's labeling them there. All right, is the point 1, 3 on the line and justify. So the way I'm going to do this, I'm just going to plug it in. This is my x, this is my y. And I have a couple choices. I can plug it into this equation, or I can plug it into the original equation. It doesn't matter. So I'll plug it into the original equation. We have 3y minus 6x equals 6. I want to plug in my x and my y. So I have 3 times 3 minus 6 times 1 equals 6. And let's see if that's true or not. I have 9 minus 6 equals 6. 3 equals 6. No, it does not. Because it does not equal, not on the line. And how do you know it's not on the line? Because you did the work. So when it says something like justify, whatever, it's basically just asking you to show work. Okay, let's move on up here. All right, you're given 2 points. And you need to, first off, find the slope. So we're going to use our slope formula, which is y2 minus y1 all over x2 minus x1. Now up here, when you're given your points, it doesn't matter which way you label them as long as you're consistent. So I'm going to label this one x1, y1. I'm going to label this one x2, y2. All right. I could have very easily labeled this one x1, y1 and x2, y2. It would not have made a difference. Okay, either way is fine. Just make sure you're not screwing up your x's and your y's. You can't have like x1 and y2 on the same. You know what I mean? You got to keep them consistent. So I'm going to go off of this one. y2 minus y1 over x2 minus x1. My y2 is 11 minus 7. Now remember, in case one of these are negatives, this negative is part of the equation. So if you do end up with a negative here, careful with your negatives. All over x2, which is 5, minus 3, which is going to give me 4 over 2. If I could do basic math, that'd be great. And my slope is 2. All right. Next, it wants the equation of the line. There are two ways for you to find the equation of the line. The first way is by using point slope. The other way is by using slope intercept. I'm going to show you both ways because I don't know which way your teacher taught you to do it, and I don't know which way you like better. Okay? So writing the equation of the line, here it is in point slope. That's the y minus y1 equals m times x minus x1. Okay? That's point slope. Again, where I have my x1, y1, x2, y2, it doesn't matter which point you pick. Either one's going to be fine. All right, so I'm going to use point 37 because I can pick that one. So I'm going to use 37 as my point. And then I'm going to plug into the equation. So I'm going to get y minus 7 equals my m is 2 times x minus 3. All right, now if it just asks for an equation of the line and doesn't tell you what form, you're good to leave it like that, and that would be full credit. Okay, but let's simplify that a little bit. I get y minus 7 equals 2x minus 6. I just distributed right there, the 2. I'm going to add 7 to both sides, and I'm going to get y equals 2x plus 1. Okay. That's if I used point slope. Now, some of you guys like to use y equals mx plus b, the slope intercept, which is fine also. I'm going to go ahead and use the same point, 3, 7. You're going to get the same answer either way. You could use 5, 11, and you're going to get the same thing, but I'm going to go ahead and keep them the same. So let's plug in. I have 7 equals 2 times 3 plus b. All right, and in this one, I'm finding my y-intercept. So I get 7 is equal to 6 plus b. Subtract 6. I get 1 is equal to b. So I found my y-intercept. I know my slope. My equation is y equals 2x plus 1. So if you look here and here, either way works, but you're going to have to be able to do that from 2 points, okay? So you're going to have to first find the slope and then use one of the points and the slope you find to get the equation of the line. Again, either one works. All right. Part C, find your x and y intercepts. Well, you already have it here. You know that this guy right here, there's your y-intercept. Okay, so my y-intercept is 0, 1. Okay, how do you find an x-intercept? You make y equal to 0. So let's use our easy equation here, and I'm going to get 0 is equal to 2x plus 1, and I'm just going to solve. Negative 1 is equal to 2x. Divide both sides by 2. X is equal to negative 1/2. So my x-intercept is negative 1/2, comma 0. And then you can graph your line. I have my equation right here, y equals 2x plus 1. So starting at 1, you're going up 2 over 1. Connect dots. My y-intercept, we know, it's right here. It's at 1. My x-intercept's at negative 1/2. Pretty close. So you're all good with that. Okay, so there is a lot of this. You are going to have to remember to, you're going to have to be able to identify slopes. So remember counting rise over run. Remember that a slope that goes this way, this is a positive slope. And then a slope that comes down like this, let me just draw it in here. If it's coming down this way, that's a negative slope. Okay, and remember it's always rise over run. Okay, you got to go up and down and then over. So rise over run when you find your slope. Okay? All right. Jump in if you have any questions. All right, we have got inequalities. Party. Here we go. We're going to solve this like we would a regular equation. I'm going to add 3 to both sides. I'm going to get 2x is greater than 6. I'm going to divide both sides by 2, and x is going to be greater than 3. Something to remember for your greater than and less than, if you have greater than and less than, it's an open circle. And if you have the equal to, it's the closed circle. Okay, so this is an open circle. I'm going to have an open circle on 3. All right, you can put it here. I'm just going to do it above it so you can see it. And x is greater than 3, which is this way. So that's the way your graph would look. There was a practice problem on one of your homeworks for this week. Make sure you guys practice it. There's a question like this on the test, but you literally have to like drag and drop. Is it open? Is it closed? Where you put it? Okay, does it go to the right? Go to the left? So make sure you guys practice that. Okay, let's do this one right here. I'm going to go ahead and distribute that -2, which is going to give me -2 minus 2x is less than or equal to -8. I'm going to add 2 to both sides, and I'm going to get -2x is less than or equal to -6. Okay, I'm just going to rewrite it up here so I have enough space. And then I'm going to divide both sides by a -2. Now, here's the other thing. When you multiply or divide by a negative, remember you have to change your sign. So change the direction of your sign, because you're dividing by a negative. So I'm going to get x is greater than or equal to +3. We have -6 and +2, so we have +3. So -6 and -2, which is +3. So I have circle. It's going to be closed on +3, and x is greater than that. So it's going that way. All right. So again, just remember, if you're going to divide out by a negative, change the direction, okay? That's when you multiply or divide by a negative. Okay. In this one right here, because you're adding to both sides, you don't need to do that. Or if you're going to subtract something to both sides, you don't need to change the direction. It's only in multiplication and division. Flip the direction of the sign. All right. Simplify using the Punnett square. So this is going to come back. There are a couple questions on here, and you are expected to be able to use various methods. Okay. So one of the questions on the exam, I'm going to give you a little heads up, will have actually a Punnett square on there and parts of it filled in. So you need to be very careful about how you go about doing that. So I'm going to go 3x and 1, x and -2. Okay. And then again, you just multiply each one to fill in the box. So x times 3x is 3x squared. X times 1 is 1x. -2 times 3x is -6x. -2 times 1 is -2. All right, and then let's see what I got. I've got a 3x squared. I'm going to put it up here. That takes care of that one. I've got these two which go together, minus 5x. And then I've got a -2. And so I'm good with that. Let's FOIL these out. Remember, FOIL is first, outside, inside, last, also the rainbow. So you're going to multiply there. X times x is x squared. Outsides, x times 3 is 3x. Insides, minus 3x, you have -3 times x. And then last ones is -3 times 3, which is -9. These guys go away. So I have a +3 and a -3. And then I just get x squared minus 9. And there's my answer for that. And then the last one, it's the same question as the first one. So we already know what the answer is going to be, but this one they want you to use the vertical method. So let's do that. Okay, I've got -2 times +1, which is -2. -2 times 3x, which is -6x. I put a 0, my placeholder. X times 1, 1x. X times 3x, 3x squared. And then there you go, -2 minus 5x plus 3x squared. So you guys can check your answers. Remember, it's the same one that was up here in the Punnett square. Got the same answer for both. All right. Okay, let's move on. We are going to simplify. This one allows you to simplify in any way you want. Sometimes I like to distribute. You can do double distribution. So what I'm going to do is I'm going to take this xy and I'm going to multiply it by all of those first. So I'm going to take this guy and I'm going to multiply it by that, and by that. So xy times x is x squared y. Xy times negative 3xy is negative 3x squared y squared. Xy times 2 is 2xy. So that's the first one. Now I'm going to do the same for the second one. I'm going to go with, let's see if I can find another color around here. Okay. I'm going to take my negative 1 and multiply it by all of these things. All right, so I'm going to have negative 1 times x is negative 1x. Negative 1 times negative 3xy is positive 3xy. And negative 1 times positive 2 is negative 2. Okay, let's see if there's anything that I can combine. Okay, you can only combine something that has all the same variables like that. Nothing else can be combined. I need to write it, I need my degree, my constant, my leading coefficient, and I need to write it in standard form. So highest exponent first. Which term has the highest exponent? Well, this guy right here has 3. There's 2 plus 1 is 3. This guy right here's got 4, 2, 1, 2, none. Here's my highest one. Okay, I know my degree is going to be 4, but let's just put this in standard form. So we're going to go minus x squared y. I'm going to combine these two, plus 5xy minus 1x minus 2. So let's do this. I've got my degree. That's the highest number of exponents. So the highest number of exponent is your degree. When you have two variables, you have to add them together. So I've got 2 and 2, which in this case, it's going to be a degree 4. All right. I need my leading coefficient. Your leading coefficient is the number in front of the highest exponents, the highest number of exponents. So in this case, it's going to be negative 3. So my leading coefficient is negative 3. And my constant is the number with no variable. So something that has no letter, and that's going to be negative 2. So in this case, it's negative 2. All right, so there's my constant, my leading coefficient, and my degree. You've written it in standard form, remember, highest to lowest exponent. If you need to find the degree of something and it has multiple variables, add the exponents together to get the highest one. Okay. Find the discriminant and determine the number of roots. Okay, find the discriminant and determine the number of roots. So here's a little crash course. Remember, for the discriminant, we're using this part of the quadratic formula, but remember, we're not using the radical part. We're just using the inside part. Okay, but it's this part of the quadratic formula. And remember how we determine how many roots it has is if what's underneath here is positive, then you have 2 roots. And remember, roots are also synonymous with x-intercepts, solutions. That's how many times your graph is going to cross the x-axis. So in this case, if it's positive, if whatever number you get under here is positive, you're going to get 2 roots. If it's negative, you're going to get no roots, meaning you're not going to have any x-intercepts, no x-intercepts. And if it's 0, you're going to get 1 root. Okay, so let's do this. There's a typo on this one right here. That should be a squared. Okay, so we're going to use this b squared minus 4ac. Remember, this is my a, my b, and my c. So I'm going to have 3 squared minus 4 times 3 times negative 6. Okay, a, b, c. 3 squared is 9. Negative 4 times 3 is negative 12. And then I have negative 12 times negative 6, which is positive 72. So I have 9 plus 72 equals 81. That is positive. I'm not asking you to do anything with it. Again, it just wants to know what the discriminant is and determine the number of roots. Because my number is positive, I have 2 real roots. Okay? And what that's going to look like on a graph, you're going to get your graph, and it's going to look like that somehow. It's going to cross the x-axis twice. Okay? There's 1, there's 2. And you know this guy's going to be a happy face because this guy right here is positive. All right, we'll get into that, but just so you guys are looking at different things. Okay, let's do the next one. I can't do anything with this until I move this guy over here. So I'm going to add 16 to both sides. That's going to get me x squared plus 8x plus 16 equals 0. Again, I'm not asking you to find the roots. I just want to know how many roots it has. So let's use a discriminant again. I've got my a is equal to 1, my b is equal to 8, and my c is equal to positive 16. Okay, remember, you got to bring that over. C is not going to equal negative 16. Okay, so let's do that. We've got b squared, so 8 squared minus 4 times 1 times 16. So I've got 64 minus 4 times 1 is 4. 4 times 16 is 64. So 64 minus 64 is 0. When I have 0, it means I have one real root. See if I can say that quickly. One real root. I think I would sound dumb if I said it fast. Okay, and what that would look like is you would have your axis right here, and it would come down like this, and it would just touch the x-axis one time. All right. And we also know it would be a smiley face because, again, this number right here in front of the A is positive, so it's going to be a happy face. All right, let's do the last one. It's already equal to 0, so I'm cool with that. My A is 2, my B is 3, my C is 2. Let's use the same thing, b squared minus 4ac. So I've got 3 squared minus 4 times 2 times 2. 9. Negative 4 times 2 is negative 8. Times 2 equals negative 16. So 9 minus 16 equals negative 7. If my discriminant is negative, I have no real roots. And what that looks like on a graph is it would look like this. Okay, there's your x-axis, and this guy doesn't cross it at all. All right. Chugging along here. I know it's a lot, but it's your final, so. Okay, there is a system tomorrow on your exam. So you are going to set up a system of equations and solve. So Arno's buying pizza for his class. He's going to buy 10 pizzas total. Let's not get bogged down in all the wording. Let's just look at what we got. We have 10 pizzas total. He's going to buy a mix of cheese and anchovy pizzas. Gross on the anchovies. He spends a total of $92. Okay? We have more cost, $8. Anchovies cost $10. Write a system to solve and find the number of cheese pizzas and anchovy pizzas that Arno bought. Okay, so I'm going to make my anchovy pizzas. I'm going to use A for anchovy and C for cheese. And again, it doesn't matter what your variables are as long as you're consistent. And I know that my anchovy pizzas cost $10. So those are $10. And my cheese pizzas are $8. Okay. And he spent a total of $92. He bought a total of 10 pizzas. So here's my first equation. My first equation is the anchovy pizza plus the cheese pizzas equal 10. Whatever number he bought. He could have bought 5 and 5. He could have bought 2 and 8. He could have bought 6 and 4. We don't know yet. But we know he's trying to spend, or he is going to spend $92. Okay, when he spends his $92, let's set it up with a money part. Okay, so we know it's going to equal 92. So let's set up this part with the money. He has anchovy pizzas. They're $10. So $10 times one anchovy pizza plus $8 for one cheese pizza. And he's going to spend a total of $92. So now we have our system. You can solve your system however you want, right? If you want to move this over and substitute, that's fine. I don't necessarily think that's the easiest way to do this. You guys are going to have to be really good at figuring out what the easiest and quickest way to go about this is. So I think the easiest thing to do would be to figure out a way to eliminate a number at the top. I can choose to eliminate the anchovies. I can choose to eliminate the cheese. So I'm going to multiply the top by -8. That's what I want to do. I'm going to multiply the top by -8 so that I can get rid of my cheese pizzas. Again, you could have multiplied the top by -10. You could have moved this over and substituted. Multiple options for solving this problem. So let me just go ahead and distribute this and see what I got. I'll do it in a different color. I have -8 anchovies minus 8 cheese equals -80. And now I have my system that I can eliminate. Those guys go away. I have 2a equals 12. Divide both sides by 2. A equals 6. Okay, so A equals 6. What did I just find? A is the anchovy pizzas. So he bought 6 anchovy pizzas. All right, so Arno bought 6 anchovy pizzas. Sometimes it asks you to write incomplete sentences. That's your answer for that. Okay, how do I find the number of cheese pizzas he bought? Well, it told me he bought 10 pizzas total. So if I have my first equation, if I have 6 anchovies plus the number of cheese equals 10, subtract, my C is equal to 4. He bought 4 cheese pizzas and 4 cheese pizzas. Okay. All right. Absolute value. Okay, absolute value. Place a check mark next to the one she got correct. Okay, so when you're doing absolute value, remember you're supposed to get 2 answers. For the majority, you're going to get 2 answers. This is in vertex form, so you can see the vertex here. And remember, your vertex is this number in here. It's the opposite. So it's going to be -3. Okay, so -3. And it is this number, as is. All right, so your vertex is the opposite of this number and this number as is. So in this case, my vertex is going to be -3, -2. So my vertex is -3, -2. That's not what they got here. So this one right here is a no. Did you get that one correct? No. Okay, not correct. Let's look here. Wants a y-intercept. How do we find a y-intercept? We make x equal to 0. So for this one right here, we have y is equal to the absolute value of 0 plus 3 minus 2. Y is equal to the absolute value of 3 minus 2. Y is equal to 3 minus 2. Y is equal to 1. All right. My y-intercept is at 0, 1. Yeah, that's true. Okay. And they wrote it correctly. Do not get thrown off when they flip it around. Okay. Yeah, the y-intercept is equal to 1 and it's written correctly. So this one right here is a yes. Let's find our roots. Okay, let's find our roots. Those are our x-intercepts. Remember, roots are also x-intercepts or solutions. Okay, all of those words mean the same. So to find our x-intercepts, we make y equal to 0 and we solve. Okay, so what that looks like is we have the absolute value of x plus 3 minus 2 equals 0. I just flipped it around because it's going to be easier. I'm going to add 2 to both sides, and I get the absolute value of x plus 3 equals 2. Okay, but remember, when you're doing absolute value, you need 2 answers. Okay, so here's my first equation, x plus 3 equals 2. Here's my other one, x plus 3 equals -2. Remember, you set up both equations. I'm going to subtract 3. X equals -1. X equals -5. So my roots are -5 and -1. Hey, great job, but it's not because these are written backwards. Your x-intercepts are -1, 0, -5, 0. Do not get tripped up on that. These questions, we seriously put them on every test. Okay, so that does not work. That's no. No. All right, these are your x-intercepts. Okay, and let's see after all of this if this graph is right. So let's look. We have a y-intercept at 0, 1. That is correct. My y-intercept is here at 0, 1. So this guy right here is fine. My x-intercepts are at -1, 0 and -5, 0. That's cool too. My vertex is at -3, -2, -3, -2. Yeah, it's all good. All those points line up. This guy right here is, yes, that is the graph of this absolute value function. Okay. Let's do the same thing again with the parabola. Okay. Y equals x squared minus 6x plus 5. You have two ways to go about solving this. You can factor it and then solve it, or you can pop it into the quadratic formula. I always try and factor first. I think it's the easiest. When I'm factoring, that's how I'm finding my roots. Remember, when you factor, it is a times c on top. So my a is 1, my c is 5, a times c is 5. On the bottom, I put my b term, and that is negative 6. And now I'm looking for two factors that when I add them together, get me negative 6. When I multiply them together, get me positive 5. So my answers are going to be 5 and 1. 5 times 1 is 5. But then I need them to add together, so I'm going to get them both negative. So negative 5 plus negative 1 equals negative 6. Negative 5 times negative 1 equals positive 5. Okay, remember you need to drop your a term. This one's easy because it's 1, but remember whatever's in front of there, you got to drop it down. So my factors are x minus 5, x minus 1 equals 0. And I can solve that. Remember, I'm solving. There's an equal sign there. X minus 5 equals 0. X minus 1 equals 0. X equals 5. X equals 1. All right. So I found my solutions, my roots. There are 2 of them. Does it have 2 solutions? Yes, it does. Okay. Let's look at the one that takes no work. This one right here has no work. You could see that just by looking at that. And the reason you can tell is you just look at your a term. If your a term is positive, you're going to have a happy face. So when a is greater than 1, it's positive, you're going to have a happy face. Okay? It's positive, it's happy. When your a is less than 1, it's negative, it's sad. Okay? So this guy right here is positive. We know this graph does not work. That's a no. Means don't do any extra work. Okay, just look at it. That right there, I'll tell you right away, it's going the wrong direction. Okay, the y-intercept is also super easy in these because to find a y-intercept, you make x equal to 0. Okay, so I'm going to plug it in here, and I'm going to get 0 squared minus 6 times 0 plus 5. But again, all that's extra work. My y-intercept is at 5. It says 5 here. But again, it's written the wrong way, okay? So this one right here is no, because it should be written 0, 5 like that, not like that. That's wrong. This is wrong, okay? That's how you write your x-intercept, okay? Let's find the vertex. The vertex, when you're in standard form, okay? Vertex, when you're in standard form, you have x is equal to negative b over 2a. Remember, it's that other part of the quadratic formula you're using. So in this case, there's my a, my b, and my c. Remember, the negative is part of the equation, so you have minus a negative 6 all over 2 times 1. That becomes positive, so I get positive 6 over 2, which equals 3. Now, I found the first part of my vertex, but I already could tell it doesn't work because this one says it's 4, and we know that that's x, y. So this guy right here is no. My axis of symmetry is equal to 3. Yes, it is. Okay, remember your axis of symmetry is the x value in the vertex. Okay. If you had to find the whole vertex, you would take this number and plug it back in. So here's the first part of the vertex, but if we had to do it, it would be 3 squared minus 6 times 3 plus 5. This is how you would get the other number for the vertex. It doesn't ask you in this problem, but just in case. Okay, and that's going to get me negative 9 plus 5, which is negative 4. So my vertex should be 3, negative 4. That's what my vertex should be. Okay, so this is a yes and no one, but if you had to find the vertex in standard form, negative b over 2a is your help. Okay, last page. Exponents and all these other fun things. All right, I kind of added some stuff to it. This one was from one of the homeworks, and I wanted to add to it a little bit because I feel like either you're getting the exponent rules really quickly and it's super easy for you and you're like, bam, I got it, or you're like, I am getting all of them wrong. I feel like people get them all right or all wrong. So this was in one of your homeworks. I copied it. There is an error in this one. So this one, I'm going to make this one positive and I'm going to make that one negative because otherwise it doesn't work out very pretty. So that's the only error that I saw here. And then let's go through. So these are your options down here. And then I added different exponent rules. Now there are a couple others which we can go over, but I just wanted you guys to get used to seeing which ones are which because you do need to understand which exponent rule you're using. Okay? So let's do this. This is going from radical to exponential form. Radical form to exponential form. This is radical form to exponential form. You guys see these two? They're kind of the same. Okay. This guy right here is false. Because when you go from here to here, remember there's like an imaginary 1 here? Okay, this should be x to the 1/3. Okay, so this one right here, the correction is x to the 1/3. It's this guy right here. All right, so this one right here is false. That doesn't equal that. And it should be x to the 1/3. Now, what exponent rule is that? The exponent rule that is, it looks like this guy right here. It's right here. So it is b to the m over n equals n rad m. Okay. This one I thought was pretty easy because you could just match it up. It's the only one that has a radical in it. It's the only exponent rule that has a radical in it. So should be pretty easy for you guys to see that one. Okay. Let's do this one. 2x to the 0 power equals 1. This is false. Okay. Yes, anything to the 0 power equals 1, but be aware of how this is written. This 0 only affects the x right here. It doesn't impact the 2. So what this actually says is 2 times 1 equals 1. And that's not true. So what should the correction be? The correction should be 2. Right? And the exponent rule, I didn't write it down there, but the exponent rule is anything to the 0 power equals 1. Okay. If you wanted to make these true, you could have also written it 2 times x the whole quantity to the 0 power because now this whole quantity is equal to 1. That is equal to 1. But make sure you guys notice the difference between this and this. All right? This one, the 0 just impacts the x. This one, it impacts the quantity 2x. Okay? All right, we got another radical to exponential. So let's do that. So radical to exponents, and here we go with this one. We have 5, the fifth root of rad x2 equals x to the 2/5 power. Okay, this is true. And just look at our exponent rule, b to the m over n. Okay, b to the m over n equals n rad m. All right, so let's look at this one. b, 2 is m, 5 is n. When I do it this way, n goes on the outside, it's 5, and m goes on the inside, it's 2. So these are correct. And on your homework, there was an option called no correction needed. So you would put that for here. And again, this was on one of your homework assignments. Okay, let's do this one. This one has 2 different exponent rules to it, but let's look at the left. On the left, you are going to multiply your coefficients and add your exponents. Multiply your coefficients and add your exponents. So in this case, my coefficients are 1. 1 times 1 is 1. I have x, and add your exponents, x to the 6th. X to the 6th power. Okay. This one right here, this exponent rule, is this guy right here. B to the m times b to the n equals b to the m plus n. Multiply your coefficients, add your exponents. Okay? I have a 1 in front of there, a 1 in front of there. I still get 1b. And then I add them together. Add up the exponents. All right? Let's look at this one. This is a power to a power. All right? Power to a power. So the power to the power is kind of like this one right here. All right? 6 to the m times n is the same, b to the m times n is the same as b to the m times n. So this is x to the 6. So x to the 6 equals x to the 6. That is true. This one is also no correction. Okay, that guy is good. All right, but we used a couple different types of exponent rules. So the first one was this one right here. The second one right here looks like this. And you guys should be able to match them up pretty easily on your test. Okay, let's do this one. This one's got a couple different exponent rules going on here. And at the end, we know it needs to equal x to the 8th. So let's try this. Multiply your coefficients, add your exponents. If I'm just looking at this part right here, this part right here is the same as this. So I'm going to get x to the 5th all over x to the negative 3rd. Okay? X to the 5th equals x to the negative 3rd. You know you can't have a negative exponent. So these guys are negative down here. You need to bring them up here. So we're going to take all of this and move it up here. So I'm going to get x to the 8th, and that's going to equal x to the 8th. That is true. And this one also is no correction. Okay. This one here, like I said, had a little typo. There was a little typo on the homework too, so your teachers can go back in and fix that. We're going to make this positive and this one negative. So multiply your coefficients, add your exponents. That gives you 2x to the 4th. Multiply your coefficients, 2 times 1. Add your exponents, positive 7, negative 3. Okay? Here's this side. This guy right here is this one over here. This is the power to a power. Okay? So this impacts all of this inside. All right? It impacts the 2. It impacts the x squared. So this guy right here, this is like saying 2x squared times 2x squared, right? There's 2 of these. So that equals 4x to the 4th. No, it does not. All right? Those are not the same. So this one right here is false. In order for that to be true, okay, we want 2x to the 4th. Our answer would need to look like this guy right here. Okay? And we're going to do this one. It's going to be 2 times x squared squared. Because this squared only impacts this guy right here, which would give me 2x to the 4th. So 2x to the 4th equals 2x to the 4th. Like I said, this was the one where there's a typo in the homework. So we're going to go 2x squared squared. Okay. All right, my friends, that is all. Hope you guys do well tomorrow. You guys have been doing such an awesome job. I'm very proud of you guys. I'm getting used to seeing your names on here, so it's great. I hope you guys do well, and I hope you guys have a good summer, and I hope you guys are, your families are okay. And thank you guys for coming on and caring about your education and wanting to pass your class. Like I said, we are very proud of you guys. You guys work super hard. So good luck tomorrow, and if you need anything, you guys know how to find us on Schoology or through email. And and a shout out to Monty, I think it was, who emailed me today telling me that I had like a bot on my YouTube. I had no idea what that was. So thank you for giving me an education and helping me out. Good night, guys.